Good afternoon, everyone. I'm Aniket Daptari. I'm from Juniper Networks. I'm a senior product manager there, part of the CONTRAIL cloud networking team. And what I'll be talking about today is what we have to offer for containerized and hybrid environments in terms of the networking solution. So we'll keep the agenda nice, clean, and simple. Quickly introduce what OpenContrail is, give you a little context. And then speak about its relevance in the container ecosystem. And then we'll talk about a customer who's using us in that context, in the context of OpenStack and containers. So we'll talk a little bit about the customer. And I've been told that we have to take questions outside. So we'll take questions after the talk. So a quick product overview. We've shown this slide at various forums earlier, so a lot of people might be familiar, but what you see at the top is something like an orchestrator. We are here at the OpenStack Summit, so one of the most popular orchestrators is OpenStack, and there may be other orchestrators like VMware's vCenter or some OSS/BSS software from Amdocs or IBM's Cloud Orchestrator. The role of the orchestrator really is it's a framework that's agnostic to the implementation and that allows application developers or consumers of the infrastructure to express app intent and express their requirements from the infrastructure in an abstract, high-level, simple fashion without worrying about the intricacies or the details of implementation, how their requirements actually get implemented in the hardware, in the infrastructure. The next box that you see on the slide is the CONTRAIL controller, and the controller plays the role of a network compiler. So the abstract requirements from the infrastructure on the network side, they get handed to the CONTRAIL controller, and the controller performs the role of a network compiler and translates these high-level abstract requirements into low-level constructs like routes, firewall filters, or routing instances, VRFs. These are constructs that an application developer either is not familiar with or does not want to be familiar with, does not want to worry about the details of how these things are implemented. But the requirement of the application developer primarily is along the lines of isolation. So typically they are deploying multiple tiers, and one of the most common requirements in terms of isolation is that application tiers are isolated from each other, and the application tiers communicate only in ways and manners that the developer desires or the developer expresses the app intent. So that they express with the orchestrator, the controller translates that into the low-level constructs. These low-level constructs are then programmed into the distributed forwarding elements. As you can see in the next layer in the slide, in every x86 compute node, you have the vRouter software that implements both distributed forwarding and distributed security or distributed firewalling at the host level, sitting as a kernel module in every host. So what happens in the container world, or what's happening is this wave of microservices, the rise of microservices. Now, before I go to microservices, we all are familiar with this picture. Do you remember this? That's Steve Ballmer from Microsoft. And for comic effect, I have this that reminds, and if you can turn up the volume, can we? Can we? Okay. So that's Steve Ballmer at Microsoft's developer convention, going developer extremely passionately. But that's for comic relief. But the idea I wanted to put across is Microsoft back in the 90s recognized the value of the developer, but that was for their their take on developers and the developer ecosystem and the importance of software in their world. But today, increasingly, and therefore, I'd like to bring your attention to the URL. That's a blog written by Matt Miller. He's an investor. He's a venture capitalist at Sequoia Capital, and he's invested in companies like Docker and Airbnb and Square and Medallia and Zoom and so on. And he's written this very nice article that explains in very simple and in a very simple language what is happening that is causing or that is fueling this rise of microservices. And what he explains is there are three things that are causing this wave of the rise of the microservices. The first one is containers. Now, we should give a significant chunk of the credit to Google that proved to the world that containers are real and they could run large applications, that large web scale applications that are consumed by literally millions of end users. They could run those large scale applications within containers. And then Docker, which made it possible for other people to containerize applications and then deploy those applications packaged with the tools that Docker made available. So Docker and Google made the containers real, or made containers more mainstream and more accessible to the average developer. Then the rise of APIs, the emergence or acceptance of APIs across the board. And the third one is the easy availability of cloud infrastructure, whether it's in public clouds or private clouds, the ability or the ease with which people could access this cloud infrastructure. So these were the three criteria, according to Matt Miller, that led to the rise of microservices. But essentially what is happening is software is becoming a critical differentiator across the board, across industries, and industries are technology focused and people are looking for more agility, feature velocity around software, and that's leading to application developers to decompose their applications into really small composable modules that become those microservices, and containers are a vehicle to deploy these microservices. The problem on the networking side with these containers is that the default networking is host private networking, and it's flat networking, extensively leverages NATing and port mapping. And in these cloud environments, what's increasingly happening is infrastructure is being shared by multiple consumers of the infrastructure, and these multiple consumers are multiple tenants. And so you need constructs of multi-tenancy or tenant isolation, and security is extremely important. So the default networking solution don't address multi-tenancy quite well. And then the ability for developers to express policy and then actually enforce or implement those policies, that's lacking. Or even if it is made available, it's the limited use of IP tables to implement policy. So these are some of the problems that our solution is trying to address. In the context of OpenStack, we have the Nova Docker drivers that allows us to use containers with OpenStack as the orchestrator. And what we do with our solution is just as VMs are first-class citizens for network virtualization, we make containers as equal first-class citizens for network virtualization. And what we do is we create the vEth pair and map the vEth pair, one end of the vEth pair sitting in the container and the other end sitting in our vRouter that takes the place of a Linux bridge or an Open vSwitch. So, and that abstracts from the underlay physical network, and the vRouters create or weave a overlay network of tunnels between them. What this allows us to do is to have an IP per container, and each time a container is spawned, the IP gets automatically assigned. The IP address management is handled by the vRouter, and then also allows policy to be, also allows groups of containers to be grouped within virtual networks. Those virtual networks manifest in the form of VRFs that we see that are carved by the vRouter on every host, and then allows policies to be applied using the orchestrator and enforced at the vRouter. So those are the benefits in the context of OpenStack. And that's our implementation, an IP per container in the context of OpenStack. And that's what the solution looks like. Essentially, if you have applications which have a mix of virtual machines and containers, you could literally have containers and VMs sitting within the same virtual networks interconnected with similar other virtual networks. But then came along Kubernetes. And Kubernetes was Google's open source orchestration system for Docker containers. And Kubernetes introduced another layer of abstraction. Rather than containers being the unit of deployment, they grouped containers into pods, and then a group of pods became services. That was essentially the language that Kubernetes spoke, and they allowed application developers to specify some metadata in the form of labels and annotations. So that was the Kubernetes world. So what we did in the Kubernetes world to speak the Kubernetes language, rather than doing an IP per container, we now introduced a daemon that listened to the Kubernetes APIs and created virtual networks on demand. And we allowed the application developer to continue specifying app intent in the form of annotations in the labels. And we inferred the app intent that was expressed in these labels and annotations. And some of the things we inferred from there were the policies. For example, the application tier interrelationships are expressed in the form of in these labels by saying tier A uses service B, and therefore we would create a policy that connects the virtual network corresponding to the tier A and the service B. So the solution, what it provides is a virtual network for every collection of pods, an IP per pod rather than an IP per container, because the pod is the unit of deployment in the Kubernetes world. We have a floating IP for the service virtual IP, the service VIP, and then behind the service VIP, there is ECMP load balancing across the service pods. So this is what the solution looks like in hybrid environments. The transition to these modern microservices world is not going to happen overnight, and we'll see a long transitionary phase where legacy applications sitting on bare metal servers, virtual machines, whether it's ESXi or KVM, and then containers, whether they are LXC or Docker or orchestrated by Kubernetes. We will see a long transitionary period when all of these will coexist. And the beauty of the solution that OpenContrail brings is that the same networking primitives apply across these different disparate environments, different compute workloads. And our solution is agnostic to the compute vehicle that you choose on the lower layer, and on the higher layer, it's agnostic to the orchestrator that is being used to express the app intent. And it speaks the language that the orchestrator speaks. Quickly talk about the customers. We have Lithium Technologies. They were a super user nominee, super user award nominee at the OpenStack Summit this year. Lachlan Evanson from Lithium was a keynote speaker, and he was also a keynote speaker at OSCon, where Kubernetes 1.0 was made generally available. And he spoke about how he's using Kubernetes in the context of OpenStack, but using OpenContrail as the least common denominator across both Kubernetes and OpenStack, across the virtualized workloads under OpenStack and the containerized or microservices workloads running in the context of Kubernetes. So there are videos of Lachlan Evanson talking about OpenContrail in the context of Kubernetes and OpenStack, what he spoke at the OSCon 1.0 launch for Kubernetes. So check that out. Follow him on Twitter, and then follow us on Twitter. You can reach out to us at contrail-plm@juniper.net, or follow me on Twitter. That's about it. Arigatou gozaimasu.